Let us just revise what you have learned in your previous classes. In a penalty kick, what makes a football move? How does a goalkeeper stop a ball? How does a hockey player changes the direction of the moving ball with a flick of the stick? How does a fielder stop a ball hit by a batsman? In all these cases, some forces have applied. In science, a push or a pull on an object is termed as force. Suppose a man is standing behind a stationary car. Will the car move due to his presence? No. Suppose the man now begins to push the car. That is, he applies a force on it. The car may begin to move in the direction of the applied force. You see, here the man has to push the car to make it move. Here what do the children do? Yes, they push each other. Here what do the two teams do? Yes, they pull each other. What about the cow and the man here? Yes, they are also pulling each other. From all these examples, what we conclude? We conclude that for a force to come into play, there should be a minimum interaction of two objects. Now you take a heavy box and try to push it by yourself. No, you are not able to push it now. Now ask one of your friends to help you in pushing it in the same direction. Yes, it is easy to move it now. Now push the same object, but ask your friend to push it from the opposite side. Does the object move? Sometimes it doesn't move. But if one of you apply more force on the object, what happens to this box? Yes, now the box moves. Now you just note the direction in which it moves. Now can you guess which one of you is applying more force here? You or your friend? Yes, it is you, because the box moved in the direction in which you applied the force, isn't it? So here you applied a larger force than your friend. In the game of tug of war, members of both the teams try to pull the rope in their direction. The team that pulls harder, that is, applies a larger force, finally wins the game. What do these examples tell us about the nature of force? Let us take the first case. Here, when you and your friend push the heavy box in the same direction, you could move the box. That is, forces applied on an object in the same direction add to one another. Now what happens if the forces are acting on the opposite directions? Here you both are pushing the heavy box from opposite directions. So here, when two forces are acting on an object in different directions, the net force acting on it is the difference between the two forces. So from all these examples, what we conclude? We conclude that some forces will be greater than the other force, some forces can be smaller than the other one, or in some cases, both of the forces can be equal. While taking a penalty kick in football, the player applies a force on the ball. Before being hit, the ball was at rest, and so its speed was 0. The applied force makes the ball move towards the goal. Suppose the goalkeeper dives or jumps up to save the ball. By this action, the goalkeeper tries to apply a force on the moving ball. If the goalkeeper succeeds in stopping the ball, its speed decreases to 0. So here what do you observe? Before taking a penalty kick, the ball was at rest. That means the speed of the ball was 0. Once the player kicked the ball, its speed increases. So a force can change the state of motion. Now what does the goalkeeper do? He tries to save the ball. Now in his action, sometimes he may be able to catch the ball. Then what happens to the speed of the ball? The speed of the ball becomes 0. Sometimes he may not be able to stop the ball, but he may be able to push the ball away from the goal post. In this case, what he is doing? He is changing the direction of ball. So by applying a force, what we can do? We can change the speed of a ball. We can change the direction of a ball. So a force can change the speed or it can change the direction of motion of the ball. Now have you seen the children competing with one another in moving a rubber tire by pushing it? Yes, I am sure you might have seen that or you might have played that. Now if you want to move the tire faster, what you have to do? Yes, you have to push the tire faster. So by applying more force on a moving object, what happens to the speed of that object? The speed of the object increases. That's why the speed of the tire increases when you repeatedly hit on the tire using a stick. Now let us do another activity. What happens when you apply a force on an inflated balloon by pressing it between your palms? What happens to the shape of ball of dough when it is rolled to make a chapati? What happens when you press a rubber ball? In all these examples, what do we see? We see that the applied force can change the shape of an object. So, from all these discussions, what we conclude? Force may make an object move from rest. Force may change the speed of an object if it is moving. Force may change the direction of motion of an object. Force may bring about a change in the shape of an object. Now the forces can be categorized as contact forces and non-contact forces. Let us start with contact forces. Can you push a table without touching it? Can you lift a bucket of water without holding it? Generally, to apply a force on an object, our body should be in contact with the objects. The contact may also be with the help of a stick, a rope, etc. When we push a table or lift a bucket of water, where does the force come from? This force is caused by the action of muscles in our body. The force resulting due to the action of muscles is known as muscular force. Animals like bullocks, horses, donkeys are used to perform various tasks for us using muscular force. Since muscular force can be applied only when it comes in contact with other objects, it is also known as a contact force. Now roll a ball along the ground. What happens after some time? Yes, finally it comes to rest. In these examples, what we have seen, the speed of objects decreases and finally it comes to rest after some time. Why this happens? The force responsible for changing the state of motion of objects in these examples is the force of friction. The force of friction acts between the surface of contacts. For example, in case of ball, the force acts between the surface of ball and the ground. When you stop pedaling a bicycle, it stops. Why? Here, the frictional force is acting between the tire and the ground. The force of friction always acts on all the moving objects and its direction is always opposite to the direction of motion. You see, if the ball is moving from left to right side, in which direction the force of friction will be acting? It is from right to left. Now, if you are pedaling a cycle from your right side to left side, in which direction the friction force will be acting? It will be acting in the opposite direction. So, the frictional force will be always acting in the opposite direction to the motion of the objects. Since the force of friction arises due to contact between surfaces, it is also an example of a contact force. So far we discussed about contact forces, namely muscular force and frictional force. Now let us discuss about some non-contact forces. Take a pair of bar magnets. Place the magnets over some round shaped pencils. Now bring the north end of the second magnet towards the first one, which is over the pencils. What do you see? Yes, here the north pole of these two magnets repel each other and the magnet over the pencil that moves backward. Now if you bring the south pole of the magnet close to the other one, what do you see? Yes, the magnet over the pencils move towards the second magnet. Why this happens? You have learned about this property in your previous classes. You know that like poles repel and unlike poles attract. When a north pole of a magnet comes close to the north pole of another magnet, these two magnets repel each other because like poles repel. When you bring the south poles of two magnets closer, it also repel. Why? Because like poles repel. But when you bring a north pole and a south pole, it attracts because unlike poles attract.